So we started the recording. So what we were going to do is we want to, let's see, um, we want to do a review for the language through examples. Tamam? So here is page down. Let's see if we can. Sometimes this hangs. Okay, this is better. Okay, this slide is very important slide لأنه بتلخص لي الفيريلوج language in one slide. طبعا احنا هنسوي examples بس خليكوا يعني معاي بدقيقة أو دقيقتين هيك نصفن في هذه السلايد. هذه السلايد تعطيني الهيكل العظمي skeleton للفيريلوج language. الفيريلوج language ابتداء هي very simple language. الغرض منها احنا we need to describe hardware. أنا عادة عندي الهاردوير there is a component. Hi, I'm drawing a component here. Okay, this component typically has interface. This is my interface. The interface means what? I have inputs and I have outputs. هذا معنى كلمة interface. I have inputs and I have outputs. الانترفيس basically هو بوابتي للعالم. And inside here في عندي ايش؟ في عندي function. Function. Okay? طيب الآن why am I drawing this؟ لأنه Verilog تنتمي إلى عائلة hardware description language. طيب تمام، ليش هو languages في عوائل؟ عندك object oriented، عندك scripting language، عندك system level، 50,000 family of the languages and every language خلينا نقول optimize لغرض معين. الفيريلوج optimize للهاردوير. الهاردوير شو في عندي؟ components. component على مستوى الجهاز، على مستوى المذر بورد، على مستوى الشيب، على مستوى البلوك. وبالتالي حتلاحظ هذه اللانجوج is موجهة is geared towards describing components. ولذلك البيسك structure فيها البيسك structure in Verilog is what? الموديول design. That's the basic structure. الموديول design is the basic structure. الموديول شو معنى موديول؟ component. وبالتالي لاحظ هنا الكيورد module end module. module end module. طيب هذا كلياته الباقي skeleton. طبعا the very first component here the very first component here is اللي هو الانترفيس. شو بيعرف لي الانترفيس؟ What's my input? What's my output? I have input here. بعرف عندي data والاوتبوت عندي result. وهنحكي عن السنتكس. Okay. Now, so this is الكومبوننت الاولاني الانترفيس هيو قدامي right؟ الانترفيس my inputs and my output. طيب الكيورد موديول. اسم الموديول انت بتساوي شو اسم الموديول؟ بدي اسميه ادر، بدي اسميه ملتبلاير، بدي اسميه ديزاين، بدي اسميه ماي ملتبلكسر، بدي اسميه اللي بدي اياه. Right? And then I define the interface, inputs and outputs. Beautiful. Then what? Then I can define my variables here. أنا دخلت على الموديول، أنا الآن صفيت هنا جوا. I can define my variables. Variables in Verilog mainly two types, registers and wires. بالإضافة للفاريبلز العاديين الانتجر والمش عارف شو هذول يعني مش موجودين دائما، بس جديد علينا الريجستر والواير. طيب الآن هذولا الديكلاريشن اوف ذا فاريبلز جزء من الهيكل العظمي. طبعا لاحظ ان احنا ما يعني خاصه اللي ما حضروش منكم المحاضرات التحضيريه لهي الريفيو probably you will not get as much depth as I wanted to. بس خلينا ايش نمشي على skeleton one pass، بعدين بنخش على example وبندعم هاي المفاهيم اللي قاعدين نحكي عنها يمين وشمال هلا. طيب الان what do I have here؟ خلصنا من ال variable declaration. beautiful. then what is here؟ what is here؟ بنقول هذا instantiation. instantiation ايوه، انا قاعد بستدعي component اسمه algorithm module. alg module right، وقاعد بعطيها اسم هنا instance name. ليش بعطيها اسم؟ لانه ممكن استدعي هاي الالجوريثم ماجل 10 مرات اذا بدي، بس كل مره بعطيها اسم مختلف، مثلا alg 1 alg 2 alg 3 alg 4 alg 10. لازم يكون الاسم للانستانشيشن مختلف، لكن اسم الماجل نفسه رايت. وحنشوف امثله على هيك later on. عندي هنا what I refer to as continuous statement right، جزء من الهيكل العظمي. قلنا ايش؟ اول شيء interface، then I declare the variable، then I do instantiation of module. سؤال، وين هاي معرفة؟ هاي معرفة يا اما قبل الماجل او في فايل ثاني، في ملف ثاني. continuous statement، لاحظ ال continuous statement has a syntax of assign، عندي variable وعندي value. assign variable value بس. دير بالك احنا مش اتفقنا عندي wire register؟ امسكوا لي هال two concepts in your brain please for the next few minutes. assign statement is applied to a variable of what type؟ wire. بلشنا نخش شوية details. تحملونا هلا. تحملونا. okay so the wire in the assign statement it has to be a wire. طيب الآن لاحظ عندي هنا initial وهنا always. initial و always. الinitial is a block that is executed once، يعني you execute it خلصنا. always is an infinite loop. كلاهما متقاربين من ناحية الرولز. هنتكلم عن one rule هلا بس، لكن الكي كونسبت انه initial block is executed once، always is executed many times. كويس. طيب ايوه، شو الفرق الثاني؟ شو اللي من خصائصهم؟ انه من خصائصهم what get assigned to هذا الفاريبل clock we assign to it inside initial block، وهي done we assign to it inside always block. أي variable we assign to it inside initial or always block it must be of what type؟ register. إذا احنا بلشنا نفرق بالفاريبلز اللي عرفناهم. قلنا عندي أنا إيش؟ عندي إيش؟ عندي wire which you can assign to this variable with a continuous statement اللي هي assign outside. باختصار outside initial and always block. بس داخل الinitial will always block when you assign to a variable what type of data it has to be. It has to be of what type؟ register. اوكي اذا بلشنا نفرق بين الريجستر والواير. الان بالنسبه للالويز بلوك it represents either combinational block، دقق combinational circuit or sequential circuit. يا سلام. اذا عندي انا ايش؟ I can have combinational. طب combinational زي ايش؟ adder multiplier الا اذا sophisticated multiplier has a control، هذا شغله ثانيه. shifter this is a combinational circuit. comparator طيب والsequential circuit ايوه الsequential زي counter عندي حكينا عن الشيفتنج بالكومبينيشنال الشيفتنج لكن اذا كان عندي مثلا انا a serial shifter right which shifts the data or linear feedback shift register it has to be a sequential circuit اوكي تمام طيب الان قلنا combinational circuit sequential circuit ما يجمعهم انه you can use always block لكن لاحظ السنتكس مختلف هنا always at asterisk او star طيب it means هذا البلوك will execute if any of the inputs changes that's what make it combinational طيب نيجي هان هذا البلوك executes only at the positive edge of the clock أيوة لأنه this is why it is a flip-flop احنا قلنا sequential circuit by the way we mean a flip-flop okay so أو negative edge of reset لما أنا أسوي reset للهاردوير ولذلك لاحظ هنا حشيك إذا الريست 0 بخلي الفليب فلوب output 0 إذا الريست else I update the output of the flip-flop by its input. This is sequential part. This is the أيوة combinational part. So لاحظ الاختلاف ب always at. شو الات هذه بتعني؟ قال لك الات هذه تعني إنه since always as an infinite loop معناها it is waiting for an event. This is an event. طب شو هو الايفنت هذا؟ هنا الايفنت هو التغيير لأني input. طب وهنا الايفنت هو التغيير معناه اجاني positive edge of the clock او negative edge of reset اوكي طيب شو كمان في فرق بين الكومبينيشنال والسيكونشال لاحظ الاساينمنت ستيتمنت هنا equal sign هنا الاساينمنت ستيتمنت شو هي less than or equal different syntax هاي بسميها blocking هاي بسميها non blocking وفي عليها اسهاب حديث كبير في الليكتشرز تبعوني if you want يعني dig احنا just we are doing an overall review here and then I can define whatever task and function here and then خلصنا end module so what I just described for you is the skeleton of a module name of the keyword module بتقابلها end module interface declaration of variables instantiation of already defined modules continuous statement initial block always block representing combinational circuit or logic always block representing sequential task and functions in module سؤال do I have to have all of them جواب no I'm just showing you what you can have you can have a module by just a single assign statement or initial block وخلص but I'm showing you here the entire skeleton of the language okay واضح is that clear now معي انتو okay طيب with that introduction let's take examples here all right I want to create a 4-to-1 multiplexer طبعا هنا مراجعة سريعة لل 4-to-1 multiplexer what's a multiplexer we have inputs of 4 data items using the select lines I can select which input goes to the output this is as simple as that and this is the circuits this is from your digital class okay so what we want to do here we're going to create our hardware here and this hardware by the way it will have this multiplexer okay so here's my multiplexer okay and I have 4 inputs here is 1 2 3 4 and the first input is A second input is B and then C and D right and I have here the select lines here, and these are my select lines, right? And I have here my output, which is out. Okay. Now notice that that the input here, these are okay. So this is what I want to do. Okay. So how can I do this in Verilog? Well, this is the code right here. أول ما نبلش module يا سلام يناظرها إيش؟ end module. This is syntax issue. طيب. Then this is the name of the module. I'm gonna call it max 4 to 1. You can call it X. You can call it my multiplexer, whatever name you want to give it to. Okay. Then watch. This is the interface. This is the interface. The interface. Okay, I have to define what? My input and output. I have input A, B, C, D. A, B, C, D. And then 3 to 0 means what? It means A and B and C are 4 bits. I love this stuff. This is really cool. طيب. And then I'm defining the output here. 4 bits as well. ممتاز. Because this is my output signal right here. Right? So let me start using, I'm starting to clutter my slide here. Okay, so this is my output here, and this is my output. Again, it is for now what happened here, he's defining registers. وفي الواقع he's alerting me that this output will be assigned to it inside an always block. Therefore, it must be of register type. مش variable, مش wire. Okay. طيب. Let's take a look at this always block. Always at asterisk combinational واضحة. Always at asterisk هذه signature of what? Combinational circuit. شو معنى combinational circuit? I don't have flip-flops or latches. طيب combinational circuits. Okay, let's see. Case select. طيب ما هو انت مش عندك سيلكت لاين هير. ايوه صح. من الانترفيس نسيت انا اقول لكم في عندي انبوت 2 bits select lines. طب why 2 bits؟ ما هو انت عندك 4 to 1 to describe which input I want to select to the output. I need a select line of 2 bits. Let's suppose I have just 2 inputs. Well, you need a single bit of a select line. Let's say I have 8 data inputs. Well, you have to have 3 bits of select lines. So since I have 4 inputs, I need 2 bits of select line. Type. Okay, so this is my always block. What do I have? Oh, I'm using a case statement. Case what? So the case statement says check the value of this select line. Okay. Check it for what? Oh, check it for these values. Oh, okay. So these are the cases that this select line will take. It is 0, 0, 0, 1, 1, 0, 1, 1. And why 4 cases? Well, because the select line is 2 bits. And 2 bits, how many combinations I can have? 4 combinations. And check out the syntax. 2 bits. B stands for binary, which means this is a value of 2 bits of type binary, because I can define decimal, hex, octal, but typically we use either binary or hex, and the default is always decimal. Okay, so لو حطيت هذول الرقمين بدون تعريف لهذا البيس كده اعتبرتهم decimal. But هو قال لي this is 2-bit value, 2-bit binary value from these 2 and B. B stands for binary. So when the select line equals 0, 0, then I do what? Then the output which is right here, is assigned the value of the input, which means this A will go to the output. The output will take the value of A. However, if the select line is equal to 0, 1, then the output will take B, right? Which means the value of B will go to the output. And if the select line is 1, 0, output equals C, select line 1, 1, the output will equal D. And these are comment statement, يعني they're not part of the code. Default out equal XX. Default شو معنى default؟ default means if the select line does not equal any of those values. طيب ما هو أنا معطيك كل الفاليو. لا في عندي أنا في الفيريلوج في عندي البت كان every bit can have a value of 0 1 and X. شو معنى X؟ X means unknown. طب شو معنى unknown؟ unknown, it means this value of the signal has not been assigned. The signal has not been assigned by the simulator a definite value, so it gets the value of X. So let's say, for example, the select here, 2 bits have value of XX. Then I will not choose this. I will not choose this. I will not choose this, and I will not choose this. I'll go to the default, which says, أيوة, إنه the output will equal X's. The case statement has this property that if you execute a branch, you exit the case statement. طب where do I go? You go to the end case. End case. And then you follow on executing the... So let's take a look at what I have here. Always, begin, and end. So this is the always block. Case, end case. You execute based on the condition of the select line. طيب حدا بيقدر يقول لي what are the inputs for this always block؟ واضحة. The inputs for this always block is A, B, C, D, and select. Meaning if A changes, or B changes, or C changes, or D changes, or the select line changes, then I'll have to execute this block. طيب إذا none of those change, I will stay here. I don't execute the block. ولذلك we say that the infinite loop, the always is an infinite loop with a conditional here based on an event taking place. No events, no execution. Okay? So this is a 4-to-1 multiplexer combination circuit. في حدا عنده سؤال؟ or اللي بتحبه الأخير I don't mind. طيب. Okay, let's go to the next example. The second example is a 4-bit counter. This time I have a sequential circuit. لاحظ المultiplexer كان combinational circuit. Now we have a sequential counter, sequential circuit. In this case, I do have a counter. Let's draw the block diagram for this counter. It's always good to have. This is here my counter. I have a counter, right? This is the value of count. Okay, so this is what? This is count, right? Count. Unfortunately, I don't have a writing pad, so I'm writing a little slow here. Count. Okay. All right. So this is my output, and then I have a clock here. This is my clock. CLK. And I have a reset here. Reset signal. Underscore n, it means reset bar. Okay. Type. Well, not the most elegant handwriting, but you get the idea. The question is, what are these? I hope we do understand what the clock signals. The clock is a signal that is in our digital system. We use it to synchronize the events. All right, and then we have this reset. This is the clock here, and this we have a reset comes in here and resets the hardware. Okay, when it goes down here. Question: why do we have to have a reset signal? Well, when you power up your system, right, you have to power up your system to unknown state. Because when you power up your system, the value of, let's work it this way. We have control circuits in our digital system. Whatever digital system, a car, dishwashing machine, the digital circuits in your laptop, in your phone. When you power up the digital system, you have control circuits in this digital system. Those control circuits are implemented by what? Sequential circuits. Sequential circuits, what's inside them? Flip-flops and some combinational. The flip-flops, when you power up, they come up with what? Random values. We learned about this feedback, right, inside a flip-flop design. So that's interesting. We power up our device and it comes up to a random state. That's very scary thought. صح ولا لا? So to prevent the hardware to power up to a random state, what do? When we power up, we use the reset signal here. The reset signal. Let me get my laser pointer. The reset signal here to inform the hardware that I want you to come up to a known state. طيب, known state means what? It means all flip-flops in the design must have values of zeros, roughly. Now, when you make the values of all the flip-flops to zeros, now this is a known state. Okay, so when we power up, we need to do this. Reset must go down, right, and inform the hardware, especially the control circuits and the flip-flops, to be in a known state. All right, so which means that if I press reset to 0 from high to low, my counter has to go to a known state, and typically 0 0, which means we reset it to 0 0. Okay, right. Now let's take a look at this counter here. Again, module and module. Syntax issues here. Simple counter. What is this? Well, that's the name of the counter. I could have called it my counter, your counter, 4-bit counter, whatever name I want. Define the interface. Input, clock. Okay, it's an input. Input, reset in. It's an input. I'm defining my interface here. Output, aywa, my output. This is a 4-bit counter from 3 to 0. Right? And notice I defined it as register. That is an indication that this count variable will be assigned to it in an always block. Okay, so now this is my always block. Okay, now notice I don't have, if you go back here, notice here always at asterisk. معناها عندما يتغير واحد من الانبوتس do execution. Execute the always block. واتفقنا الانبوتس اللي هم ايش؟ select والاي والبي والسي والدي ما حدا منهم اتغير ولا بسوي شيء. بظلني استنى هان عند الات رايت ده واحد من هذول يتغير. ما حدا تغير ما بسوي شيء. طيب نيجي هان لا الموضوع اختلف. كيف اختلف؟ قال لك هان انا ما بدي اسوي اكسكيوشن الا اذا صار واحد من هذول اثنين. شو هم هذول اثنين؟ pause edge of the clock. pause edge of the clock يعني الكلوك تغيرت من 0 الى 1. This is typically the flip-flop. or طيب شو الايفنت الثاني؟ neg edge of reset. لما الريست تنزل from high to low ما حصل واحد من هذول الاكتيفيتيز، خليك واقف هان، ما بدي اياك تتحرك. Okay, so this is the trigger of going into this block انه I receive a pause edge of the clock or a neg edge reset. طبعا I'm assuming I have a clock which is created وموجودة بالسيستم إلى آخره. طيب الآن دخلت على البلوك. افترض إنه أجاني لسبيل المثال reset low here. So when the reset goes low, immediately I will get into this block. What do I need? I check لأنه احتمال إنه يكون reset واحتمال يكون ما في reset. If reset invert the reset signal, which means this is now true, then the count I will assign it to 4-bit 000. What does this statement mean? It means I want to assign to the variable count, which happens to be my output, this value 00. طب ليش بكرر هذا 40؟ لأنه أصلا هو 4 bits. هيو 4 bit 000. يعني all the bits of the count variable will get zeros, which means the 4 flip-flops here inside will be now set to 0. Why? Because I received a reset that goes from high to low. طيب بلكن ما مش هاي الكيس، بلكن أنا أجاني pause edge of the clock like here. This is a pause edge of the clock. Then else it is not the case that reset had. Then else طبعا يعني مثلا بده يكون الريست ما نزلت للو. يعني مثلا بدها تكون الريست ايش زي هيك. ده مثلا so this is a positive edge here وأنا reset is high. Reset here is high. So I am in this event here. Okay, which is what? So this is my clock actually. This is my clock. This is clock. Okay, so this is my CLK. Okay, and this is my reset. Okay, now when I'm at this event, I received a positive edge of the clock, right? So I get inside this loop. Is the reset 0? No. Which means I have to update the counter. How? Count gets the value of count plus 1. I need to increment the counter, right? Because it's a counter. And I received a positive edge of clock, it has to count. Okay? So the counter will increment in this case, right? And خلصنا من البلوك، باجي بستنى هان، بستنى للnext event للpositive edge or the negative edge of the reset وبشيك بالif statement. Okay, if reset صفر الكاونتر، مش reset زيد الكاونتر وكنتينيو doing so. في شغلة غريبة هان ما بعرف إذا لاحظتوها. لاحظ الاسايند ستيتمنت كيف شكلها less than or equal. المثال اللي قبله كان equal, right? طب شو الفرق بين اثنين؟ قال لك هاي الايكوال اسمها blocking assignment and typically used for combinational circuits. كويس؟ هذه non-blocking assignment typically used for sequential circuits. طبعا في شرح كبير عنهم، مش وقته الان وانا اشرح بالاكزامبلز، right? بس typically this is what you use الblocking non-blocking assignment for sequential circuits والblocking assignments for combinational circuits. واضح؟ Is that clear? Okay, خلصت من اللوب، انتهينا. This is the end module. So in this case, what I did, I described a sequential circuit 4-bit counter with reset, okay, using this module definition. طيب Any questions يا جماعة؟
دكتور begin بتكون تحكي يعني begin the instruction.
begin زي الكيرلي بريسز في السي. هان يقابلها هاي، هاي يقابلها هاي، هاي، فهي بتعرف a block.
اوكي begin واخر to end.
Yes, yes, like الكيرلي بريسز اللي بنستخدمهم في other languages.
تمام.
Okay, any other question يا جماعة؟ طيب. Okay, now يعني again I meant for these examples حقيقة إنه you really kind of get a good start على language. Okay, so now in this case we want to do a full adder combinational. Oh, but a test bench. Okay, so what is a test bench? Let's define with a test bench. Well, cool. Here's where the story starts. You build something, you have to test it. If you build something without a testing, then I have no idea what you are building. For quality assurance, you must test and verify. Okay, all right, so we got that. We must test our design. How do I test my design? Well, the way to test your design, let's just say here, for example, it's a full adder. You build another module called a test bench, right? Where you instantiate يعني you call this block inside the test bench, and you feed it the values of the inputs such that you validate, you verify the behavior of the design that you have designed. Okay? All right. اتفقنا احنا هيك الحين؟ وضحت الفكرة؟ You need a test bench, right? القصة تبدأ إنه when you design something you have to test it. طيب. Therefore, I designed something here: adder, multiplier, encryption engine, a neural network, whatever you want. You have to test it. To test it, I need to build a test environment. And in this case, it's a simple test bench that typically we need for simple design. طبعا for larger design, you have to have really a full-fledged verification environment. And this is beyond the scope of our course. But let's just, baby step here, take baby steps and talk just about the test bench. So the test bench is another module, right, where you call your design and change the values of that design. Right. Here's what we're going to do. What we will do here is that we're going to have our, we're going to have our design here, okay, which is, okay, this is our test bench. So this is our test bench, okay. And then we will call the we will call we're going to instantiate our design here. This is the adder inside the test bench, right? This is our design. Typically, we refer to these generically as design under test, or dot, the dot. And then typically you have inputs here that goes inside the dot, and you have output that leaves the dot. Now, what happened, typically your test bench should produce different values for the input of the dot. And somehow you have to observe the output of your dot. You can do that visually, with a print statement, there are so many things. Okay, so you see how this skeleton working? You see how this architecture? This is my design here. This is my design right here. This is my design, right? This is my design. Okay, whatever I am implementing, a multiplier, an adder, okay, but it has to be called inside the test bench, and I have to change the inputs of the design, the values of the inputs, right? Then I observe the output. افترض انه مثلا your dot عبارة عن, let's say, TV. Right? You said, can you please test this TV? So what you do, you take this, you start pressing the buttons of the TV. Well, does the turn off switch works? Right? A change of the channel works. USB plug, does it work? So you start applying different scenarios to the inputs and observing the output to validate the functions. Because the dot has features, right? This TV works if you press the power button on. Well, I have to test that feature. So what do? I press the power button on. If I press it and the TV doesn't start, then that TV is a failure product, right? It is defective. But if I press it and the TV starts, then it is a working feature, that feature particularly. And I have to do the same things for everything. So that's the purpose of this guy here. Right. Let's see, what do I have here? I'm assuming I have a full adder here. Okay, so this is my full adder. Let's see. Okay, so again, what do I have here? Sorry, I keep. Okay, this is the module, end module, syntax issue, the name of the adder. Oh, what are the inputs for a full adder? Well, we studied full adder, right? We know it has inputs A, B, C, N, and outputs sum and cout. Okay, good. All right, so here he's using wires here. Yeah, he's defining variables that will be assigned to these variables outside always an initial block. Twice. Type. So what are these here? Oh, he's describing an adder here, full adder, not behaviorally, rather structurally. Okay. You see if I can pull one of the slides of from my class here, so that you can associate. Let's see. See. If I can get this here. Mm-hmm. No, this one here. Probably. Okay, I think there's one here. Not this one here. Looking for, by the way, just to let you know that I'm looking for here we go. I think this is the one here. Okay, I think I can probably do this here. No. All right. If I may, this would not allow me to do it here. طيب مش مشكلة. Let me discard this. Let me try it. Okay, I think you're seeing what I did here, يا جماعة. Do you see what I did? I went in and I brought you the circuit that we are implementing here. متابعين معي? Do you see a circuit اللي جبتها?
Yes, doctor.
Okay, so this is a full adder we have from our digital logic class, and this full adder we implemented it with exclusive OR. طبعا pardon me هنا هو مستخدم A B C and أنا عفوا مستخدمين X Y Z, and then the output here is sum and carry out. Okay, so معلش adjust your reading. But what is he doing here? he is implementing الgate level, وهذا مختلف عن اللي سويناه قبل شوي. لاحظ هذا مالتيبلكسر. طب وين الجيتس هان؟ ليش ما سوى زي هيك؟ قال لك اذا بتسوي زي هيك بالجيتس اسمه structural design. طيب وهذا الديزاين شو اسمه؟ اسمه behavioral. You are describing the behavior. طب شو الفرق بين البيهيفير والستراكشر؟ اللانجوج بتعطيك الحريه انه you express the behavior او you express the logic gate زي ما بدك، وهذا له استخداماته وهذا له استخداماته. فأنا في هذا الإكزامبل بعطيك الادر implemented in terms of a structure. رايح لاحظ XOR gate، هاي الXOR gate، XOR gate ثاني، هاي XOR gate ثاني، بيطلع لي الاوتبوت sum. هذول الانبوتس، وفي اللي في الاولاني الاوتبوت. لاحظ هنا هاي W1 اللي هي هان. if I add this this is W1. okay, this is A, this is B, okay, and this is CN. Sorry, not coming perfect as I want. Okay, طيب الآن so this is W1, and you can see that the input is A and B and produces an output of W1, which is this gate, right here. Okay, and then we have this gate 2 takes W1 and Cn and produces an output sum, which is this gate here. Let me change the color. Okay, all right, good. Right, لاحظ الموديول name الانستنس name. module name, what's the module اللي هو الجيت. XOR instant name inputs output. But then what? Then I have this gate here. Let me change color here. Maybe probably do a blue here. Okay, and this is what here? What do we name this here? This is W3. Okay, and this one is this gate right here. كويس. And then I have okay, this one here will produce for me G3. It will produce, let's see if I can get so this is G3. Where is W2? Okay, this one here will be W2. All right, and it is this gate. Okay, you see that? Okay, in inputs, W1 CN, W1 and CN. Well, output is W2. Okay, you can see that clearly. And then finally, I've got, let me have another color here. Finally, what do I have? I can use what now? This magenta, probably. All right, which is this gate here, G5, which is this one right here. Okay, which will take W3 and W2 and produces C out, which is this one here. This is my C out. Okay, so again, oops, sorry. Again, what I have done, I have described the structural design. Structural معناها gate level. كويس? Do I have to do this in my assignment? No. You choose the style that you want. But I'm just showing you and demonstrating for you the capability of the language. طيب الآن اوكي راحت لنا رسمة التست بنش مش مشكلة. الآن what we have here is that now this is my test bench. Look at it, module. This is my full adder. TB معناها test bench في full adder. This is not a keyword. You can call it my test bench, your test bench, whatever. دقق. We don't have input and output. احنا قلنا الفيريلوج you have to have an input and output. الفيريلوج you have to have an input and output if it is a physical component. زي الادر المultiplier. بس التست bench it's not a physical component. It's a program that we write, then we throw it away. But what's the useful of why do we create a test bench? To test the design. So the test bench does not correspond to hardware. What corresponds to hardware is the design itself, right? Okay, so here is my adder here. I instantiated the adder. Full adder, that's module name, full adder. Then what is a UUT? It's an instantiation name. I can call it U1. I can call it X. I can call it B. I can call it Sammy. Instantiation name. I can give it any name. In fact, I can if I ignore it, the tools sometimes they will create their own. Okay, then what? Dot A, dot B, dot CN, dot O. These are the interfacing signals for the full adder. You see, A dot A, B dot B, CN dot CN, sum dot sum, C out dot C out. So these are the interfacing signals for the full adder. And I'm doing what? I'm getting inside this module السيجنالز اللي انا بدي اوديهم من التوب ليفل. ما هو انا على ليفل هذا الفول ادر عندي انا سيجنال اسمها تي اي بشبكها بالاي في الادر. تي بي بشبكها بالبي بين بي في الادر. تي سي ان بشبكها بالبين تبع السي ان للادر. تي سم بشبكها بالسم تبع الادر. تي سي اوت بشبكها بالسي اوت تبع الادر. So these are the signals, right? These are the signals for my top level. أنا هيك شبكتهم بالادر. هيك أنا شو سويت؟ وصلت السيجنالز اللي على مستوى التست بنش جوا للديفايس. زي كيك شبكت بالوايرز. يعني إذا أنا بتخيل التست بنش عندي بورد هير وهاي تشيب عندي الفول ادر وصلت بوايرز للبنز للاي والبي والسي والوايرز اسمهم تي اي تي بي تي سي ان تي سم. طب شو تعريفهم هذول؟ لاحظ تي اي وتي بي وتي سي بعرفهم ريجسترز. معناها انا بدي ايش؟ I will write to them in an always or an initial block. بينما T sum و T out they are wires. okay. طيب الآن بيجي عن الانيشال بلوك. الانيشال بلوك اتفقنا it is executed once. يعني it's not an infinite loop. okay. It is executed once. Now طيب now we have this initial block. okay. Monitor, this is a monitor statement مشان to monitor الاوتبوت والانبوت. انا اللي بيهمني هان what am I doing in this section. what am I doing in this section يا جماعة؟ انا بغير الفاليوز تبعون التي اي والتي بي والتي سي ان 0 0 0 0 1 0 1 1 0 1 1 1. okay. These values, as I change them, they will change the pins on the adder, and I'm going to observe the output of the adder. And by changing the inputs of the adder and observing the output of the adder, now I can verify the behavior of the adder. okay. طبعا المونيتور statement says that لما يتغير واحد من هذول اللي هو تي اي والتي بي والتي سي والتي سي سم والتي سي اوت، اطبع الستيتمنت هذه اللي بتعطيني التايم في السيميوليتر، الفاليو تبعت الاي، الفاليو تبعت البي، الفاليو تبعت السي ان، الفاليو تبعت السم، and I can verify it by the screen or by the waveform. Now initial end, what is this? dollar sign finish معناها finish السيميوليشن and you can halt the simulation by dollar sign stop. End module. okay. What did I achieve here, or what is the purpose of this? This is a test bench for what? For this adder. okay. So in this test bench I define the variables, I instantiate the adder, and then I change the values for the signals that are connected to the adder pins, and I print the values of the inputs and the outputs, and this way I can verify the adder behavior. طبعا these are not enough patterns, but this is just an example by the way. okay. حد عنده سؤال؟ حد عنده سؤال؟ I'm talking يعني very condensed here. خليني اخذ بريك لحالي هنا شوي, and then we can continue with the with the fourth example. okay. Let me take a break. What I'm going to do is, most likely I will go and stop the recording, and we'll start it in the second section.